Yeah, good afternoon to all of you, and good morning and good evening for some of you. So it's a great honor and privilege for me to welcome you all to the Air Quality Management lecture series. And we have with us the person who initiated air quality management in India. So I will welcome Professor Mukesh Khare to the event. And before that, this lecture series being organized jointly by Department of Civil Engineering, IIT Madras, and CEPHA network, which is sponsored by UK Hari, and Indian International Conference on Air Quality Management. Again, it's another initiative which is being supported by Professor Mukesh Khare in this endeavor. So now, without taking much time, we will briefly introduce about CEPHA network. I ask Dr. Madhusudan to say a few words about CEPHA network, and followed by I'll request Gopika to share, introduce the speaker, and then Professor Khare will start the lecture.
Yeah, good afternoon to everybody. It is a pleasure to invite or welcome Professor Mukesh Khare to this fourth series of our lecture series on CEPHA network. CEPHA network stands for the Clean Environment and Planetary Health in Asia. It is founded by a group of research organizations, government partnerships, and also the NGOs. The aim of the CEPHA is to enhance the intersectoral, interdisciplinary engagement to co-create the lasting partnership that will help to initiate a clean environment in Asia through low carbon development, focusing on innovative solutions that can provide multiple health, environment, and socio-economic benefits. Under this aegis of CEPHA, under this project, we have started the lecture series. In October, we have started our first lecture series, and today we are having the fourth one. And apart from the lecture series, we also conduct programs for the school children as part of the World Environment Day and also part of the India International Air Quality Conference. So a lot of activities are going on under this CEPHA network, and we are glad to invite Professor Sir for the fourth lecture series, Air Quality Management India Way Ahead. Thank you, sir. Welcome.
Thank you, Dr. Madhusudan. Now I'll request Gopika to introduce Professor Mukesh Khare. In fact, this today's afternoon program will have three parts. One, sir will give, Professor Khare will give you the lecture on air quality management in India way ahead, and followed by some of the research collaborators, his past students, and maybe the last segment of the students who have worked extensively from 3 to 4 decades in this particular area. So we will try to discuss about air quality management, past, present, and the future. So that will be the workshop, and we are glad that some of the eminent speakers who are already working with Professor Khare have been agreed, and Professor Khare will going to chair this particular workshop. And followed by, it's a great honor for all of us, as a student of him, to felicitate to his or acknowledge as a token of appreciation. All of us get mentored, and we got a lot of things through our interactions when we are working with him. So we will do that one maybe around 4:30 as a felicitation. So now I'll request Gopika to introduce Professor Mukesh Khare.
Good afternoon, all. It is my privilege to introduce Professor Khare today. Professor Mukesh Khare is a distinguished professor at the Department of Civil Engineering, IIT Delhi. He is the Fellow of Institution of Engineers, India, and Fellow of Wessex Institute of Great Britain. He is a chartered engineer and was born in Varanasi, India. He obtained his PhD degree in Faculty of Engineering from Newcastle University, UK, and has managed a range of environmental projects throughout his professional career. With a specialization in air quality modeling, Professor Khare's experience has covered research and development studies, teaching, consulting, modeling, and editorial activities. In addition, Professor Khare has authored more than 250 research publications, primarily for peer-reviewed journals and conference proceedings. He has 30 years of teaching and research experience and is a distinguished member of many committees of National Green Tribunal and Environmental Pollution Control Authority. He was recently appointed as an expert member of high-level task force chaired by the Prime Minister's office to deal with increasing air pollution problems in Delhi National Capital Region. Sir, we welcome you.
We welcome you, sir.
Yeah, thank you. First, I would like to thank Mr. Madhusudan and Dr. Shiva and Gopika at last who introduced me. Thank you, Gopika, and thank you, Shiva and Mr. Madhusudan. So good afternoon from India to all. Good evening to those who are joining this event from countries like US and Europe. So good evening to them, especially good evening to Shally, one of my ex-students from here, who is a professor at UCLA in US. So good evening to her. So with this, my objective of this lecture is sharing my experience for last 30 years in air quality. That is decade by decade, that how our air quality management progressed in India. What was it 30 years ago and what is now, and what would be the future? What are the challenges that India is going to face in managing the air quality? So let's start with one of the concerns on air quality in various categories of urban areas, which I have mentioned over here, including the rural population. There are two major categories. If you want to divide the urban India, is the metro cities and then urban areas that consist of Class A, Class B, and towns and other cities. And also, it consists of growing cities of India, which is in number approximately 104 growing cities. And the second category of urban India is the critically polluted areas. So if you see these two categories in urban India, there are various subcategories of these metro and small cities, which we call it as a non-attainment cities, which are not meeting the air quality standards. Up to 2018 or 2019, if I'm not wrong, the number of these non-attainment cities was 102, and now it has become 122 as per the latest statistics from Central Pollution Control Board. Among all these non-attainment cities, or even the attained cities, which I called it, which cities which are urban areas, which whose pollution level are below the standards, the dominant sources are vehicles, exhaust, small and medium scale industries, the solid waste burning, road dust, which is resuspension of the dust from the road, small and medium scale industries. Construction is one of the major source of the particulates nowadays in most of the urban areas and metro cities, because India is expanding like anything. Very fast expansion is taking place. And the landfill emissions. I won't say the landfill, but I can say as the land dumps in most of the cities, where the wet waste, the biological wastes are dumped, and which results into the emissions of methane, ammonia, and H2S. So these are dominant sources in almost all the cities and urban areas of India, whether it's attained or non-attained. And these cities are experiencing the air quality exceedances, mainly in terms of the particulate matter 2.5 micron size and 10 micron size, and nitrogen dioxide. These are the two major pollutants which are exceeding the standards, apart from other pollutants like ozone, that is tropospheric ozone. In some places, there are some exceedances of benzene also, which is represented in form of VOCs. So depending upon the type of sources, you see the exceedances. But in general, the 2.5 and PM10 and NOx in almost all the cities, they are exceeding, non-attained cities. Main concern that how to reduce that. And vehicular emission is one of the major sources. So the government of India planned 2010, way back in 1998, 1994, right, to change the transportation fuel, because we first hit the transport because the vehicle number was increasing like anything. Then we went for CNG, we went for LPG, and now from 1st April 2020, the BS6 has been introduced. The concern is that how these change in fuel is going to be implemented throughout the country. Presently, these change in fuel application is mainly restricted to some cities, not all the cities of India. So that's the concern now. Then change in the vehicle engine technology, which 1990 onwards, the Ministry of Road, Ministry of Transport, and Ministry of Heavy Industries. These are the two major ministries concentrating on change in the vehicle engine technology. Now, this is restricted to four-wheelers. The engine technology change, like, nowadays, the engine technology has been improved a lot. And now we are trying to leapfrog to the electric vehicle, technology, to use the electric vehicle. But there's a concern again, because how to implement that? What are the infrastructure required for that? So all these things are there, which becomes a concern for the air quality, though we have started working on that. Then comes the critically polluted areas in this city. That is, most of these areas are having the industrial clusters. And to address this concern, the IIT Delhi group has developed a comprehensive environmental pollution index. We call it as a CEPI, about 10 years back. And this CEPI is used as a guidelines by the Central Pollution Control Board and by the industrial clusters that it should be below a certain level. And CEPI includes not only air quality, but also the water, waste, land pollution, and health. All these four areas have been included in this index. So that is another step which the government of India has taken. And IIT Delhi was leading in developing this index. Most of these critically polluted areas are experiencing the pollution from these industries, that is thermal power plants, TPPs, refineries, and petrochemical plants. These are the major industries in this critically polluted area, apart from small and medium scale chemical industries. And major pollutants include the nitrogen dioxide, again, particulate matter of 10 and 2.5 micron, the VOCs, the pH, and sulfur dioxide. These are the major pollutants, apart from other, depending upon the raw material and the fuel used in these critically polluted areas. So these are the urban areas. Then comes the rural areas. In rural areas, the main concern of air quality remains still the indoor air pollution. That is the use of biomass by the women to cook the food, use of coal, use of kerosene in many of the villages. So that restricted to indoor air pollution, and which is a concern for the air quality for us. As far as outdoor air pollution in rural areas is concerned, they are mainly unpaved roads, the biomass burning, generator sets, etc. Right? So these are the outdoor air pollution in the rural areas. And major pollutants in these sources are again particulate matter 10 and 2.5 size, carbon monoxide here, and ozone, which is tropospheric ozone, which is an emerging pollutant and which we find a lot in the rural areas. So these are some of the concern of, in air quality in urban and rural settings of the country. Next, please. Now, these are the various urban sources. Now, I'm concentrating on the urban sources over here. One is the motorized traffic. As I told you, vehicular emission is one of the major sources, followed by industries, the kitchens, the open burning of the solid waste, which you can see the biomass, the diesel generator sets. Construction, as I told you, is expanding countries, so a lot of construction is going on. Some of the areas in India are also experiencing the agricultural residue burning, which you see as the stubble burning, you can see, and which is predominant around Delhi, that is Punjab and Haryana, which makes the air quality worse during the period of these harvesting season. Then road dust, and then the migration of the dust or pollution from the surrounding areas outside the city. So these are the major urban sources which is existing almost all the cities and all the urban areas in the country. Next, please. Now, as far as causes is concerned, a general cause which you find from most of the cities and urban areas in India are these four. The category can categorize in four major classifications. First is the uncontrolled sources, unaccounted sources, then geographic location, and naturally the last is the meteorology. That is the wind speed, velocity, humidity, and temperature. Among all these fours, the concern is mainly unaccounted sources. There are still many sources which have not been attended to. When I say attended to, there are no emission load is available for these sources. So when emission load is not available, we cannot do any forecasting. So we cannot do any effective and efficient management of these sources. The best example which I can give you for this unaccounted source is the road dust, which is a diffuse source and which has not been attended to in most of the cities of India. And that is, the studies have found that 25 to 30% of the air pollution in most of the cities are due to the road dust. So these are unaccounted sources which are a major threat and concern for the air quality. Next, please. Now this slide tells you right from 80s up to 24 to 2020, I think it's a 24. Huh? Okay, so it's a 5 years NCAP. Okay, this is a program for the NCAP which is for the 5 years. That is the visionary program, a strategic program. So this tells you a very interesting slide that 81, we passed the Air Prevention and Control of Pollution Act, not too long ago. Then 84 ambient air quality standards were introduced. Then 2009, the standards were revised. Then AQI 2014 air quality index, which is used all over the country now. Now, if you see, very strange, there's PM 2.5, which is a cause of concern as far as air quality is concerned. 2016 it was included for all manual stations, so not too long ago. So we can say it's only 4 years old child, right? And PM 2.5 is one of the major cause of health concern in India. And see the timeline. Then the latest is the NCAP, that is National Clean Air Program, which is a strategic program introduced in 2 years back, I think. 2018 it was introduced, I'm told, and 2019 it was started. That's for 5 years. And latest, only last year, November, we have also created a commission for air quality management, which is taking over the EPCA, that is EPCA, in 1998, which was formed, that is dissolved. And also the high-level task force at the PMO level, that is also dissolved now, as taken over by the Commission for Air Quality Management, that is CAQM. So these are various regulations and organizations or which regulatory steps which government has taken. Next, please. Now, how to deal with these sources, how to deal with these causes of air quality. This is a chart which gives you the urban air quality management framework, which is self-explanatory. And the green box tells you that we have done sufficient work in this area. When I say sufficient work, we have sufficient data now. The only thing is that we have to have a proper use of these data in terms of forecasting, so that a proper management can be planned for the cities, right? So that's the green box is telling you, right, from air monitoring, source apportionment, emission inventory, and the red boxes, which are many, if you compare with the green, tells you that a lot has to be done in that. As far as I'm concerned, I think a lot has to be done. And in this, to accomplish or to change it into the green, I think it requires a collaborative approach between regulatory agencies, institutions, laboratories, and academic institutions. So a collaborative work has to be planned properly. Then we can convert these all red boxes into green. And I'm pleased to share that this step has been started. Many collaborations are being done by institutions, laboratories, national laboratories, with regulatory agencies. Now, on the left side, there are two elliptical boxes we have showed you. That is the health study and impact analysis and cost benefit analysis. These boxes are completely disintegrated till now from the regulatory and academic and other air quality analysis work. But the need has been already felt by various institutions at the government level as well as regulatory level, that air quality ultimately affect the health of the receptors, which is human beings, which in turn affect the GDP. So it is very important that the doctors, epidemiologists, the biologists, the botanists, all these people should brought into the arena of the air quality specialists and experts who are engineers, scientists, so that again a collaborative approach with these people can be planned. Similarly, the cost benefit analysis requires economists to work with the air quality experts, and this has to be done right from the beginning, right from the data collection. These people must be working with the experts and engineers, right? Then we can have a proper outcome and proper planning and management. Next, please. Now, at the moment, we have done a lot in the local air quality management, in various cities. People are actually working at the local scale as well as urban scale and regional scale as well. As far as local air quality management is concerned, it has been drawing attention that we have to collaboratively interact with public, private, and NGOs, which can provide a lot of input in the managing the framework of the air quality management, and it helps in avoiding the unnecessary regulations, and it also promotes clarity in decision making process and certainty as well. So I am pleased that in last 10 years, local air quality management has become quite strengthened in many cities, in particular the metro cities of India. Next, please. Now, these are some of the slide which I want to share with you. What is the present status of the monitoring in India? Most of these monitoring stations have been established all over the country, which statistics shows you on the left-hand side. And it tells that these monitoring stations are established based on the population. But I think that the work is required more, that not only the population, but many other criteria must be considered to establish these monitoring stations, depending upon the severity of the air pollution in that particular area. Next, please. The work which had been done in last 10 to 20 years in the country, right from 2000, if you see, we started a campaign. These works are the campaign. It is not an individual or institutional works. These are the campaigns which have been planned in the country at a large scale, where collaborative efforts were done. That involves institution, academic and research, both laboratories, national laboratories, NGOs, and regulatory bodies. See, I have listed all these, like 6 city studies started in 2001 by Central Pollution Control Board. The target pollutant was PM10. And these 6 cities were covered all over this. And most of these cities were metro cities at the time. So these, the first of the large campaign was done, which gave a good experience and very good outcome of this city. Followed by, if you see the listing, by IIT Kanpur, then IIT Madras and IIT Delhi. Again, we covered the city Delhi. Target pollutant was 2.5. Source apportionment is going on in almost all the cities and all the states of India at the moment, on the order of NGT, that is National Green Tribunal. 122 non-attainment cities have been covered in the source apportionment. We are trying to see what are the sources which are emitting 2.5 and which are emitting 10. So we will apportion these sources so that the proper control can be done on these sources. So that is the cities which studies campaign which have been done in the country. Next, please. Now, while managing this air quality, we need a good forecasting tool, and these forecasting tools can be done by the dispersion model, by using the dispersion model. See, the tree dispersion model is comprising of various types of dispersion models, right, which has a different mathematical principles like deterministic, statistical, physical, and these are having subcategories. But at the moment, as far as regulatory model is concerned, the box on the left side, which are colored with the blue color, they are used for the air quality management because they are simple model. The input data are not too complex, which is required to run these models. And though they are very highly conservative model, but they can be used, they are used very successfully at the moment. However, I feel that among the dispersion model, if you see one box which I have put in red, I think we require also to develop our own numerical based model, which we call it as a dynamic puff model, so that we can use the Lagrangian mathematics to follow those smoke and those puff in the atmosphere and see that how the characteristics of that puff of smoke changes with meteorology at different time and different space from the source from where it is generated. So that is called the numerical based Lagrangian model. So that has to be required to be done. A lot of work has to be done on that, and which are more accurate and more realistic than the deterministic model. So that work is required in India. Not much has been done in that. On the right-hand side, receptor models has been used mainly with the chemical mass balance model, which needs source profile, which is a bit complicated because you have to have a detailed source profile in order to have an accurate predictions. And the most used and model as far as receptor is concerned is the positive matrix factor, matrix factor analysis model, which is called PMF model, where the source profile is not used as an input. So it becomes a bit simple, but it requires a lot of data because it's a statistical based model. So these two models are generally used as far as receptor is concerned in any air quality management framework evolution. Next, please. Now, these are the experience of our students who have done PhDs, masters in the last 30 years, that for the city of Delhi, and a couple of models have been used in the city of Chennai. Which model is a fit for urban air quality prediction. So you see the table. I don't have to go each and everything, and see that in this, if you see that neurofuzzy based modeling is the most model which can satisfy all the characteristics of the urban air quality modeling. However, this model has its own limitations. The data limitations, the experts, the formation of expert group, etc. So then it is preceded by the artificial neural network based modeling, which also is quite a good model based model, and which predict the episodic conditions as well. So these are various type of model which fits the urban air quality predictions, and depending upon the data availability, you can choose any one of them. But among all, the deterministic models are the simplest one, though they are highly non-conservative and not satisfying or following all these characteristics which I have put in the left-hand side column. Next, please. As far as research on urban air pollution is concerned, I have just summarized last 30 years. What are the fundamental research? What are the technology development which has being done actively in the country? And what are the policies and interventions? So this is not the whole list, but this is some major initiatives in these categories, which has been taken and which is being done at the moment. As far as fundamental research is concerned in air quality, as I told you earlier in the last slide, that numerical based air quality models, these are the area where fundamental research is to be done. I think requires a lot on that. Followed by urban air pollution and health, which I already covered in that. A lot of work has to be done in collaboration with doctors and epidemiologists. A group has to be formed, and followed by indoor air quality, which is at infant stage in India. We don't have much of the data on the indoor air quality. We don't have standards so far. So we have to do a lot in the area of indoor air quality. Under the technology development, these are some of the active projects which are being taken. For example, the artificial intelligence-based decision support system, DSS, for air quality forecast, which is being recently accepted by the Commission for Air Quality Management, where a group of experts are doing this project so that we can have a DSS, a decision support system, based on artificial intelligence, which can be used for forecast and management can be evaluated. Then sensors-based air quality monitoring, that is also one of the technology development taking place in the country in order to increase the spatial resolution of the existing air quality monitors, which are expensive. The fixed monitors are very expensive, so we cannot use a lot in the city. So in order to substantiate those gaps, sensors are being maybe used. So a research is going on various technology development in the area of air quality sensors. And then the control, the filtration-based ambient air quality control, many research, many technology development are being taking place. And I'll show you a couple of slides ahead, like NIRI is involved in that, IIT Delhi is involved, and many other institutions, including NGOs, freelance researchers, they are making a lot of filtration-based air quality control equipments. As far as policy intervention is concerned, the major research or major initiative which is being taken by the regulatory agencies and Government of India is the hotspot identification action plans in all the cities of India. That how to identify hotspot and how and what action plan has to be planned to protect the occupants of that hotspots. And that is being done using the decision support system, which is under construction at the moment. The software is under construction. And the policy intervention is also looking at the indoor air quality standards, the IQ standards formation. That is also being looked after by the Central Pollution Control Board and Ministry of Environment and Forest. And I'm pleased that IIT Delhi is leading institution in the indoor air quality research work, to help the government that how to evolve the standards. And the third policy intervention was airshed. Yes, I just forgot to write that. It is a very recent, policy and interventions by the Government of India that the air quality should not be seen as a city-wise like Delhi, but it should be tackled based on the air district or airshed. Like Delhi is being affected by cities from Haryana, Punjab, and Uttar Pradesh. So we have to make an air district, identifying those areas which are influencing the Delhi atmosphere. And then we should draw a line, a boundary for the this air district. So this airshed approach of the air quality management is another interventions or policy initiative taken by the Government of India. And our national laboratory, which is called NIRI, National Environmental Engineering Research Institute, which is a nodal environmental laboratory in India, is working on framing the airshed for Delhi. So this would be the first of its kind of project of airshed when it will come out. So they have just started about 6-7 months back. Yes, please. Now, these are some of the strategic program which I have listed, and you can get on the various sites of the India. But just to highlight, among all these program, the FAME program of the Government of India is quite, taking the speed using towards the electrified vehicle. How the electric vehicle or electrified vehicles should be used in India. So that is called faster adoption and manufacturing of hybrid and electric vehicle. So this is the program supported by various ministries. National Clean Air Program, NCAP, is launched in 2018 by the ministry and now taken over by the CPCB, who is implementing this. And then Smart City Mission, which is known world over, the 100 smart city development in the country. So these are some of the strategic programs. Next, please. Now, some of the interventions which has been taken place in last 30 years is all these things I have given over here. The interventions which has been shown in red I told you earlier also, I discussed it with you, that these interventions, have been dissolved now, and it is now, represented by the last, one, the CAQM, that is the Commission on Air Quality Management, right? So otherwise, the National Green Tribunal, the Graded Response Action Plan, that is called GRAP, AQI, Air Quality Index, and recently construction demolition waste management rules in some of the interventions. Most important is the Pradhan Mantri Ujjwala Yojana. This is a very important intervention, very effective intervention, which has been done by this government, because that has protected millions of the women in rural areas. As I told you in the first or second slide, the first slide, I think, the rural areas, the main pollution is indoor air because the women use the biomass, the wood, coal, etc. How to protect their health? Because that ultimately helps the, affect the children. So this was taken by the government, and then they started supplying the gas cylinders to all these rural areas. And millions of areas have been covered, and they have supplied the gas cylinder, free gas cylinders. They have supplied the free first. Later on, they have to fill the gas themselves. But so that helped a lot in reducing the indoor air pollution, and so this is quite an effective intervention which has taken place. And then from Bharat Stage 4 to Bharat Stage 6, this is also a very major intervention from 1st April 2020 all over the country. Though gradually, these Bharat 4 to Bharat 6 is being gradually filtering out to other cities, but Delhi, Mumbai, Bangalore, they all, I think, gradually converted to BS6. Next, please. Now, these are some of the interventions which I have tried to explain that they have been implemented in this slide. We call it as a bi-weekly action plan for effective and efficient management of PM2.5 concentrations. So this bi-weekly plan have been designed by us in IIT Delhi using the deterministic conservative model, Gaussian-based air mod. And this is being used very successfully by the Central Pollution Control Board during the winter season. Now, this intervention is now going to be taken over by the DSS, which is Decision Support System, which is a bigger scale, larger scale, involving many other institutions, which I will tell you in the next slide. But this is at a very short scale that CPCB is using this intervention, during winters. Yes, please. This is just a media attention when this program was launched by Central Pollution Control Board, that how the media took this intervention. So this slide tells you. Next, please. Now, this is a decision support system, which is being taken over by, being worked over by the various institutions involved in that in a large scale. And the Commission on Air Quality Management is sponsoring or supporting this initiative. And let's look at from the left-hand side, TERI is involved, that is the Energy Research Institute, in emission inventory part. The chemistry component is being done by the Indian Institute of Tropical Meteorology and Indian Meteorological Department, where they are going to use the WRF-Chem model. Engineering component will be looked after by IIT, IITM, Indian Institute of Tropical Meteorology, and NERI, so air mod and local server, that is engineering component. And fuser model will be done by the, Indian Meteorological Department. This model is a very high resolution model of 400 meter by 400 meter resolution. It takes care of that, at the hotspot scale. So CDAC will be the application platform, that is Center for Development of Applied Computing. The high power computing where CDAC will take is a Government of India organization which will operate and run this DSS, and CPCB and the Commission will be the interactive user of this decision support system. So this is being done by the at the present is started. Next, please. As far as air quality management and control, the chronology is concerned, I'm trying to put you here, various slide, 10 years, 1 decade, what happened. And, I will cover some major, air quality initiatives out of all these, which is listed over here. In the first slide, if you see that, the relocation of the polluting industry, phasing out of the older polluting vehicles, introduction of mass rapid transportation. This is one of the very major initiatives which has been taken over during this decade, where the CNG conversion, the metro programs in the cities, metro rail programs, and then the older polluting vehicles like 10 years old diesel vehicle, 15 years old petrol vehicle, you cannot run. They are just have to be deregistered. All these changes have been done in this decade. And then use of alternate fuel like conversion of CNG from petrol and diesel to all commercial vehicles have been taken place in this decade. And apart from ethanol, petrol, methanol, biodiesel, hydrogen, these are the things which are going on, and research is going on. Somewhere, some application is also being taken place in some cities as well. Next, please. Next decade, 2000 to 2010, the major initiative was the city-specific air quality management action plan. This was drawn on the order of the NGT, that is National Green Tribunal, where it has been mandatory for all the cities, especially non-attained cities, to draw their air quality management action plan. And almost till today, almost all the cities' action plan has been finalized, and they have started working on that, to control the air pollution. And the other major initiative in this decade was the revised NAAQS, that is National Ambient Air Quality Standard, which was revised from the old standards. And the first one is the corporate responsibility for environmental protection, where the industry was brought in, and they were told that out of their funds, some funds they have to relocate towards the responsibility for environmental management. So this is another major initiative in this decade, which has been taken by the government. Next, please. Then 2010 to 2020, lot of initiatives have been taken place related to the air quality management and air quality control. And out of them, the major was the public participation, metros, alternate fuels, electric cars, and buses. This was started in this area, in this decade. And most awareness was program were taken to make the public aware of the air quality, that how it is harmful. Then leapfrog from Bharat 4 to Bharat 6, that is a major initiative, very strategic initiative, that we just forego the Bharat 5, that is the Euro 5, and we directly came to the Bharat 6, And then the AQI, that is Air Quality Index, was also evolved during this decade, which is extensively used all over the country and very useful for the general public, who don't understand the microgram per meter cube or any other technical words. So this air quality index gives them an idea what is the pollution level they are exposed to. And after that, better traffic management, another initiative or interventions during this 2010 to 2020 decade, which took place, where a lot of changes were done. More flyovers in the cities were, constructed. Subways were constructed. T-junctions were closed. Regular, information on the traffic flow through radio, through the screens, through the TV, or all these things. In many cities, if you go, you'll find these things. So that started in this decade. And then the NCAP, another important development in the air quality management, is a National Clean Air Program, a strategic program which has been evolved in this decade. And then lastly, the formation of Commission on Air Quality Management, which has been formed just in November 2020. Next, please. Emission norms and fuel quality for vehicles, that will give you a slide which I would like to share with you, that how we changes from BS1, that is Euro 1 to Euro 6. So this tells you the chronology, that how did we do it. And we are not bad. I think we did really well in this changeover from fuel quality. Next, please. Similarly, that percentage diesel, how it was reduced from the fuel. And we see that we did really well right from 1996 to 2020. And our diesel percentage is now reached at 2.001% in the sulfur percent in diesel, which is as clean as petrol. That's what we are using, and we call it the Bharat Stage 6. Next, please. These are some of the interventions, the major interventions I'm showing you over here. After the extensive research and development, for example, Vayu, this is one of the air quality control equipment, which has been designed by the National Environmental Engineering Research Institute. And you can see various equipment of Vayu in Delhi, which has been put up in various intersections and some straight roads and some hotspots. Mumbai also, you can see this equipment in various shapes. So this is one of the major intervention, and it not only cleans the particles, but also gases. And the zone of influence approximately is about half a kilometer around that. So it creates a clean air zone. So those who are suffering from asthma, from asthmatic, etc., they can, if they are going or walking in that area, if they're feeling some bad air, they can come to these regions, sit down over there, get some clean, fresh air, and then, then walk again. So that is the purpose of these type of control equipment. So this is a major intervention. Then satellite-based application for air quality monitoring, that also, after extensive research and development, many satellite-based data has been used by the controlling agencies and supplied to the government and regulatory agencies so that they can issue the orders and norms based on these satellite and remote sensing data. Ambient air quality monitoring stations, mobile stations, were evolved and designed and being used by many state boards and Central Pollution Control Board as well. Then in the area of sensors, a program was launched by the Government of India in about 4 years back under the Uchchatar Avishkar Yojana, which is a higher invention planning program, where a project has been given to IIT Delhi with the Physics and Civil Engineering Department and IIT Madras included in that, and one of the private industry. We call it as a Sensure Air project, which designed a holographic based sensors, which gives not only the mass measurements, that is the microgram per meter cube of 2.5 particles, but also gives the shape. What type of particle is it? So this sensor is called Sensure Air. The patent has been filed, and very soon, within a year, I expect that the production will be started. Then the decision support system, which I have already talked. So it will look like something like that, which you see in the slide. It's just a artistic view of one of the DSs, where you can take policymakers, regulators, and researchers sit together and can take a database, objective decisions. So this is another technological intervention, I think, which you can see in coming to a couple of years' time. Thank you. Next, please. Now, mitigation technology 2010 to 2020, some major mitigation technology I am listing over here. So dust suppressant, which is being used and done by test has been done by NIRI also. There's in Nagpur, and in some places where 30% reduction in 6 hours have been observed if you use this suppressant. Then mechanical sweepers, most of the cities are now using the mechanical sweepers to avoid the resuspension of the dust. Then many type of technology to collect the APM 2.5 from the atmosphere has been developed, and one of them is ionization technology, which has been tested by the Department of Science and Technology, that is DST, at various places. So that has been tested, and we are expecting that this technology is being maybe used for developing some products, air quality control products. Then air quality index, smog guns is used invariably at almost all the construction sites, so that particle can be, whatever the particles are generated when various construction processes can be arrested. Windbreakers, now all the sites, they have mandatorily, they have to use these windbreakers so that a particle cannot go out of the area where the construction is taking place. So these are some of the major intervention. And last is the smog tower, which is being constructed in Delhi at 2 places. So it will be the first of its kind, so the control in city, right, when it will run, because it's only 6 months back that we have started this. IIT Bombay, IIT Delhi, and National Building Construction Corporation, that is NBCC, and Tata, Tata Construction. These are involved in constructing this smog tower of 29-meter high in 2 places in Delhi. And it is an experimental tower, but we will see that if it is successful, then it can be used as one of the ambient air control technology. Next, please. Now, after giving these 30 years of progress and development in air quality, there are challenges which are still existing, and which a young generation working in the area of air quality has to see all these challenges, try to find out the solutions of that. So I have listed about 8 challenges over here. Now, right from the ambient air monitoring station categorization, that has to be reworked, because we don't have a proper category. We have a broad category, but not the micro level category. Then air quality forecasting and early warning system, calibration and measurement protocols for the air quality sampling and monitoring instruments. Still, we don't have these in a very systematic manner. We don't have certification of the measuring instruments that we have to create. Indigenous air pollution measuring instruments, that a lot has to be done in that, because most of these equipments we import. The major challenge is the citizen-led air quality management, which is completely absent in some of the cities. You can see some of the RWAs are participating, that is Resident Welfare Association, but still we require a lot to be done so that citizens can become a driver of the air quality management. Then leapfrog from diesel, petrol to electric vehicle, that is a big challenge for us. And the last is the capacity limitation, that is in terms of human resources, experts, and qualified engineers, financial resources, etc. So these are some of the challenges which I have listed, which the young generation, young population has to tackle in the area of air quality. Next, please. So what is the way ahead? How to deal with the challenges? Way ahead is that one has to plan in a very systematic way that how the appropriate siting of air quality monitoring station has to be done. Think on that, so that the present air quality monitoring locations where the fixed stations, which are very expensive, have been fixed. You can find out what are the lacuna, if there are any, and what are the best location site, and then try to document those appropriate siting criteria. That has to be evolved. Then categorization of the ambient air quality monitoring station. The categorize, at the moment, we have 4 broad categories: residential, commercial, industrial, and eco-sensitive. But I feel that we have to come out of these conventional broad category of the air quality monitoring stations. We have to go some more micro level stations, like a roadside station, curbside stations, within the residential area. Those residential area which are near the road, they should have a separate station. A big residential area, I'm not talking 400, 500 people, but settlements, big settlements. So roadside station, curbside stations, these are some of the micro level location or categorization has to be evolved. So that you have to think. Next, please. Then use of hybrid monitoring system. That also is a very high, a way ahead that you can think of doing some work in this area in air quality. Sensor-based air quality monitoring network. A lot of sensors available. What is the quality of the sensors? What is the calibration? How the calibration is to be done? How we can do the field calibration protocol? All these to be developed so that sensors can be used successfully between 2 fixed stations. And spatial resolution of the monitoring can be increased. So this is another challenge with us, which you can work on that, the young people. Then using alternative technologies to fill the data gaps. Again, satellite-based monitoring integrated to the ground-based monitoring. That has to be evolved, so that a proper integration, a proper conversion, or mixing of the satellite and ground-based to be done, so that the decision-making process becomes more accurate. Another important challenge with us is to cover the diffuse sources like road dust, landfill emissions, construction dust, because they are all diffused. They are not point sources. So, and we have to see the emission load of that, because they are creating more than 30% of the pollution within a city, right? So we think that drones can be used, housed with sensors. And these drones can cover a lot of area in one of its drive. So what are the drones quality we should use? How the sensors to be placed on the drones? What is the payloads of the sensors, so that drones cannot be affected? It's a driving process cannot be affected. All sorts of things where a lot of work and research is needed, and application is needed to see that. So a high resolution emission inventory can then be created using these type of technologies. Next, please. Then decision center for DSS. This is another challenge with us. That makes such type of decision center where all people can sit together, regulatory agencies, policymakers, researchers, and they can show you with the data that if you do it, various scenarios can be developed over here. That if you close 100% of buses, if you shut down 20% of TPPs, if you do that, then what would be the standard concentration of particles, NOx, etc. So then policymakers will see, okay, economically also they will see, so that not much of the cost is affected. Technically feasibility, they can see this of the action, and then they can take a most optimized action plan can be drawn. So think on that sort of decision center should be created, not only because India is a big country, not only at one place in Delhi, but also it should be a regional decision center should be there, so that people can come and use this facility, and they can be self-sustained as well, because not only necessarily the government should aid, they can be sustained. It can be a paid task. Yes, please. Then another way ahead or challenge with us is the documentation on the measurement and calibration protocol. We don't have any standard reference methods. I mean to say we have, but we don't have any documentation on that. So we should have a proper documentation published from the Central Pollution Control Board, the standard reference methods, standard reference protocols, so that these methods and protocols and a proper documentation is available on site. And any people can download those things and then follow that particular reference methods, so that all over the country, the uniformity is maintained in terms of sampling, analysis, monitoring, and calibration. So these type of documentation is required, which is a huge, a gigantic task, which you can think of as a challenge. Next, please. Then National Environmental Standard Laboratory, that is how to certify the equipment, sensors, many equipments. So I'm pleased to share this slide that recently on 4th January 2021, our Prime Minister has inaugurated the National Environmental Standard Laboratory, which will be housed in the National Physical Laboratory campus of the Delhi. So it will be first of its kind of the certification laboratory. So I think Central Pollution Control Board is one of the partners in that, and they are going to, and I think NPL UK, they are collaborating with the NPL Delhi. So they are going to develop these standards laboratory, which will take time, a couple of years, I think it will come, but initiation has been done on that. Next, please. Then development of indigenous instruments. As I told you, we import most of these automatic instruments from abroad. So in instrumentation, those people, those young students who are working in instrumentation, they can think of developing these digital or automatic air quality monitors, so that we can save our foreign exchange and we can develop our own instruments under the Atmanirbhar Bharat program. So that is also a challenge with us, which is requires a lot of attention on that. Next, please. This is the biggest challenge which I feel in last 30 years, that why we are not able to control the air quality, which should have been controlled, but we could not. Why? Because the citizens are not a part of this management. And when I talk citizens, I'm not talking the 10% or 15% population in the city. When I say citizens, I am talking of the citizens of 70% India living in the either towns and rural or semi-rural India. I think involvement of those citizens are required. And the best example for young people, for young students, I would say that go to this website. I was, as one of the advisory board member of this European Union supported project, and I learned a lot from this project. Go to the site, read this site, see that how citizens are being involved, right from the children to a 90-year-old person in air quality. I'm not saying that Western people are involving all the cities in Western nation. No. In some of the countries, like in Poland, in European countries, the conditions are not as good as we think over here. There also the problem of citizens' involvement is there in the air quality management. But with this type of programs, with this type of projects, if you can plan, you can also do a lot of success, that how to motivate students to be, citizens to be involved in any air quality, because air quality cannot be controlled by law, by stick, carrot and stick. Air quality only can be managed. Control is not possible. What I mean to say, if there are 100 polluters, if they, among 100 sources, and if there are 2 or 3 polluters, then you can regulate them by law. But if out of 100, there are 98 polluters, law cannot work. You got to change your approach. And that approach is citizen-led air quality management. So that is the biggest challenge we have. And the next decade, I think people, the academicians, students, researchers, laboratories, NGOs, they should start thinking in terms of that. Whatever they do, try to involve public. So that is my appeal, and that is the greatest challenge I feel. Next, please. Then presently, the diesel petrol to EV, this is a very big challenge for us. That how to leapfrog from diesel to EV. There are controversial views on that. But my personal view is that leapfrog will not be very effective and efficient. I think we have to go with a very smooth transition from diesel, petrol to hybrids, and then hybrids to the electric vehicles. So that is my feelings. And some of the points which I have written: what are the feasibility and what are desirability of EV mandates. So if you see these 2 columns, if you read that, you can see that how big challenge it is in India. But so you have to think carefully and see that if you have any program on that, any thoughts on that, you can always go for some good projects on that, so that you can come out with some good policies, a good initiation, so that this program can be successful. Because this is a program which is being supported by the Ministry of Road Transport and Ministry of Environment and Forest. Next, please. So that's all I wanted to share with you for last 30 years, what I have done, what has been done in the air quality, some major initiatives, some major interventions, some major policy decisions which Government of India has taken. And I feel that you from this presentations, you will have more idea evolved in your mind, more constructive ideas, have a more constructive contribution, and more the contribution which can come out with some good outcome, some positive outcome for the country, where we can reduce our air quality and we can protect our ecosystem, we can protect our humans and children. Thank you very much.
So thank you very much, sir, for the wonderful lecture. It was very useful to covering from the starting to various aspects of air quality management and the future requirement. Maybe there are few questions we can discuss, or maybe you can give your views on that. One asked by Professor Shyam Gupta ji. Gupta ji has asked, should we initiate PM1 measurements, because that is from the health aspect and also from the chemical characteristics aspect. So should we start doing PM1 measurements in the urban area? So your comment on that one, sir.
Yeah, thank you, Mr. Gupta. I think PM1 measurements, it is the best time to start parallelly with all fixed stations, which we have at least in most of the cities, and under the NGT program, NCAP program, where the government of India has given a lot of money for the fixed stations to establish. I think it's the best time to, also include the PM1, because once we get some data in next 2 years, couple of years, then it would be possible to analyze those data, and then we can have, a proper control and management policy for the PM1. I agree with you. I think it is the best time now to start the data generation on PM1.
Yeah, thank you very much, sir. There is another question which Gupta ji also raised. So should we, right now the CEPHA continuous ambient air quality monitoring stations are not being linked to air quality management plans. Should we make some efforts towards that direction, so that the air quality management plans can be developed based on the CEPHA information?
I think CAQMS in some cities, like in Delhi, all these CAQMS data is taken by the Central Pollution Control Board. So as far as Delhi is concerned, yeah, as far as the Delhi NCR is concerned, I think not all the stations are linked to one of the central stations. I think that is what the air quality management, cannot be done. If we want to do, involving the airshed district or air district. So yeah, it is required if we are going for airshed based air quality management. So all the data which are collected in that airshed has to be, used for the air quality management plan. So all the CAQMS in the airshed has to be connected to a central data repository, and that is required. I don't know, because in Delhi, the airshed is being constructed by NIRI. So once the airshed is finalized, so I think that the next step by the CPCB should be, which I'm sure they must be thinking, that how to link those CAQMS with the data repository center over there.
So thank you very much, sir. There is a last things, and then maybe we'll start with the panel discussion, and some of the questions maybe we can also take it during the panel discussion when you are chairing that panel discussion. And so the last question, sir, there are a lot of discussion on quality data. So we have sufficient infrastructure in order to get air quality data, so that will be useful for air quality management purpose. So this question being raised by Dr. Sunil Kumar Tyagi. Do we have a sufficient infrastructure in terms of making assurance for quality assurance and quality control for air quality data?
This is Mr. Tyagi has raised a very important point on QA/QC of the data. I also feel, I agree with him, that QA/QC has to be documented by the Central Pollution Control Board, and then it should be followed by the State Pollution Control Board, so that right from the source where the data is being generated or taken, the QA and QC can be maintained. At the moment, I feel that there is no proper methodology or protocol for QA/QC for the data. it is all based on either personal interactions of the people who are using the data from the stations, or so there is no public QA/QC or open QA/QC documentation. I think it should be generated by the agencies like Central Pollution Control Board.
So thank you very much, sir. There are so many other questions are there. Maybe probably we will take it up during the panel discussion. So
Okay.
on behalf of air quality management lecture series, which we have initiated through your guidance, thank you very much for giving this wonderful lecture. I'm sure that all the participants who are attending this particular event will all get benefited, particularly the younger generation will get a lot of ideas about this lecture. So thank you very much, sir. So now I'll
Thank
move
you.
on to the